Hi, everybody. Welcome back. This is our first lecture for section 4, which is our last section in this course. Congratulations for making it to this point. I hope you've enjoyed yourself, and I hope you find the remaining content just as enjoying. For this particular section, we're going to be working with some advanced queries, mainly on the read side, because that's where we tend to spend a lot of our time writing more complex queries. And my thoughts for this section are along the lines of talking about query discriminants, which determines which records would be returned from a pool of records, and query projections to filter that return data out. In other words, I don't want this column or that column. Sorting data, how indexing helps with all this, pagination, and then finally just a little example with aggregation. I know in the previous section when we were working with the user models for PHP and Python, the code, I had made reference to going into some advanced programming using session management and session handling. And unfortunately, that was outside of the scope of this particular course. I do apologize for leading you astray on that particular topic. Perhaps later on we can revisit that and I can come up with a new coursework for aggregation and advanced queries in MongoDB using multiple tables. Be that as it may, this is the final section. It's going to be a lot of lecture, some command line examples using the Mongo shell, but again, it's just mostly introducing you to these concepts. So today, what we're going to be talking about, or in this particular segment, what we're going to be talking about are query discriminants. And a query discriminant, as you know, is a group of one or more terms that filter out our desired set of data from this huge, massive data pool. Now, if up until now, we've been working with a very small data set. As a matter of fact, our user collection has consisted of a single record. But imagine, if you will, that you're working with tens of thousands, hundreds of thousands, or even millions and millions of user records. And obviously, for several considerations, you don't want to execute a select splat type of a query against these large tables with terabytes or even petabytes worth of data. In other words, you don't want to fetch all the data. You want to be very selective on the data that you do fetch when you do need to fetch it. And most front-end applications, internet applications, support this. And we'll talk about that more in the section on pagination. But for now, our query discriminants are a tool that we use to limit the amount of data coming back to us from the database. In other words, if I've got 10 million users in my database and I'm looking for a particular subset of users, obviously I don't want to retrieve all 10 million users and then use code to filter through that data set to find the users that I'm looking for. If I'm going to write a program to that method, I might as well use flat files and forget about using databases entirely. Instead, we want to put the heavy lifting on the database engine itself. That's what the database is meant to do. It's meant to very quickly parse through the indexes, hash things out, and give us exactly the data we want, no more and no less, at the fastest speed possible. So to that, I've come up with a few sample queries that could be real world queries. And excuse me for reading off the slide to you. I know you've probably already read them while I've been talking. But we're basically going to look at some more complex queries using operators or logical operators, if you will, comparison operators, more succinctly, in Mongo. And these queries are, give me a list of all the employees that were hired in January by engineering that received less than 1,000 stock options. So obviously, this is an AND query. We're looking for employees from engineering hired within January with minus 1,000 stock options granted to them on their hire date. That implies that we're going to be searching at least 3 fields in our collection. Those fields, of course, be the hire date, the department, and their stock option grant. The second query, how many customers made orders totaling more than $100 in the last 30 days? This could be a very important question. It could be interpreted in multiple ways. It's not an aggregate query. I'm staying away from aggregation for the meantime. So I'm looking for single orders totaling more than $100, not one customer making 3 orders of $50 each. In this particular query, that customer's orders wouldn't show up because none of the queries were more than $100. And the curveball here on this particular query is that we're looking for a dynamic date range. In other words, we don't know when this query will execute, but we want to look at the current date and then calculate 30 days backwards to figure out our orders that satisfy the query criteria. And then the third query is how many books are currently priced at either $10 or $20, or are on sale for less than $5 and were published in the year 2012. So that's a little bit more of a complex query. We're going to be using multiple operands there, and we're going to be using and or and grouping that together. So I'll show you how all these queries parse out in Mongo. But first, I want to talk a little bit about query discriminants and aggregation. From the very beginning, when Mongo was first released, Mongo was advertised and proselytized as a document-based database, and as it is today. And back in the very beginning, early days of Mongo, there was no aggregation. Aggregation, I think, was introduced around 3.2, I believe. And you worked entirely within one single collection for your queries. And the trade-off for that, what you were basically doing was using Mongo to store denormalized information, as opposed to a relational database like MySQL, where you can break out your data based upon their hierarchy or based upon their relationships. For example, customers and customer phone numbers could be 2 different tables. Whereas in Mongo, we would denormalize that, and we've talked about this before in previous sections, where every customer has a subarray field with all of their phone numbers listed in it. And the premise here was that storage, online storage or cloud storage, was becoming cheaper and cheaper. Disk space was way more cheaper than processing power, processing time. So let's just try to denormalize our data set so that we can execute and return the data that we need in a single query. And that was the whole revolutionary at the time idea behind Mongo, and it took off like wildfire. When you compare this to current database requirements, MySQL is an alternative to Mongo, and of course it's a relational database system. And if you're familiar with this, I'm sorry, you can kind of, go get a cup of coffee or something. But if you don't know about this, it's worth listening to. In the MySQL database, the database engine is optimized to handle more complex queries. And so you have things like joins, where you join several tables together. So if I want to make a query about customers, orders, and inventories, I could join all 3 of those tables in a single query and execute. Now, the processing power or the cost of that query would be borne by the database and the database engine optimizer to figure out what was the best way based on indexing, based on the data, to provide you with the response that you were asking for. And MySQL does a really good job, and they have more tools in their tool set than Mongo does. They have database objects such as views. They have stored procedures and stored functions, triggers, events, etc., that allow you to even offload more of the programmatic processing work onto the database engine, as it should be, in return for speed. So in other words, if I write a program in SQL, a stored procedure, or if I write a view which restricts or joins my data views, that would execute much faster than executing the native query because it's already been precompiled or tokenized by the database engine. Mongo doesn't have these luxuries. Mongo is fast, it's agile, you get in, you get your data, and you get out. And some of you guys may respond with the comment, but MongoDB has Lookup. And Lookup is Mongo's answer to the MySQL join. So as a document-based storage system, Lookup again was released in version 3.2. It provided a pseudo join operation across multiple tables or multiple collections. And I say pseudo because you could only use it in aggregation. Now, you've heard me use aggregation, and previously in this series of courses, we covered a section on aggregation along with some samples, just as an introduction. But we haven't really dove into aggregation deeply. At the end of this section, I'll give you my go-to aggregation query that I use quite frequently, actually. Generally speaking, aggregation queries in MongoDB are very complex, and because they're complex, they're difficult to maintain. If you've only got one MongoDB guru in your company and he leaves to take another position, the rest of you who have to take over that database for him until you get a new Mongo expert are going to have kind of a bad time. Even if you're a MySQL expert, if you're looking at aggregation in Mongo, it kind of makes your eyebrows touch a bit because it's not straightforward. It's not easily decipherable. Whereas you could look at an aggregation query, comparable aggregation query in MySQL, and pretty much suss out what the user intended when they wrote the query. So from the example on the right, you can see an aggregation query, and I believe right here we have our lookup, which says what we're looking up from what collection, not native to the current collection we're currently searching on. And my point here is that if you're using lookup a lot in your application programming or in your web app, if you're using lookup a lot, you're probably using the wrong schema to store your data. Again, MongoDB's strength has always been in fast retrieval from a single collection, and MySQL's strength has always been in managing relationships. So if you've got a highly intensive relational data model to implement, by all means, I would strongly urge you to consider MySQL for a storage solution instead of trying to maintain that relation within Mongo and using aggregation. You'll save yourself, trust me, a lot of pain and headaches down the road.